Hey guys, my name is Jonah, and I'm going to be going over my Project 2 network intrusion detection. In the beginning we just have a bunch of imports here, and the second box here is all of the method declarations that the professor offers to us. Okay, so down here I read in into a data frame from the common separated value file network intrusion. And then right here I set some columns. Just print that out to see what it looks like. There's 42 different columns. And then for the pre-processing of the data frame, I remove duplicates. So get those out of here. And I also just wanted to look at the data types. So I just printed that for testing. And down here I'm going to attach the attack types. I think there was like 22 or something like that. So what I'm doing here is I'm dropping values inside of the data frame that are not applicable. Cleaning up the data a little bit, and then also replacing things that maybe have typos, so normal dot to with normal, if that does exist in there. And then also I am creating two data frames, one good and one bad. Basically, if the data frame column outcome equals normal, then I'm going to put it in good, and then every single thing else is just going to go into bad, because it's not normal, it's an attack type. And that gives me two data frames. Here I have two types of values for the info types dictionary. There is either continuous or discrete in the method, or not in the method, but sorry, in the PDF for this problem the professor put symbolic, but when you go to the appendix it's discrete. If you go to the web page it's discrete, so I kept it pretty ubiquitous. And then a for loop, basically going through the dictionary looking for continuous and assigning it a z-score for later processing. And then mapping using the professor's provided method, which is 0 to 1. Basically anything that has and the outcome, which is normal, will get 1, and everything else is 0. It might be the other way around. But yeah, it's good or bad for the binary problem later. And then down here is the first fully connected layer. So I'm just going to go through my results now, because I think I'm already even a little over time. I did a bunch of different configurations, the same thing, with the 3 activators and the 2 optimizers, but I'm going to look for the best and the worst. Here I've got an accuracy and an F1 of 0.51. But I'm actually going to look for my worst and my best. A 0.80 here. And then I also have, I think there's a 0.8 or a 0.52 here, so this is kind of not bad, but worse. And then here we go, a 0.86. So this is a fully connected layer, and this is 30 epochs. It just takes 2 seconds each time. It just takes a lot of time, so I didn't do much more. So this is with TAN and SGD. And then here's our findings here, an accuracy of 0.86, an average F1 of 0.86, so not tremendously bad. And here's our confusion matrix right here too, to give us a visual representation of what we found. And then from here I'm just basically going to move on to the convoluted network. Don't know if I'm even saying that right, but somewhere down here, and train, a little bit lower. Here we go. So this is the first one that I have, and I think that this is the worst one. So the only difference that we have here is I had to convert X into a NumPy array, then I had to reshape it, which I do right here. And then Y hot encoding is just being printed because it was already hot encoded using the professor's provided method. So then we send it through with TAN. This is pretty much the same configuration that is in Professor's Lab 10. So yeah, but just a different, so the same code, different configuration, a bunch of different configurations. So this is with TAN, and I compile with SGD, and then I use the same print statement I did above, but just adding an extra label, which is worse, to provide a little bit more information. So this one didn't do, actually it didn't do horrible, but it didn't do good. So 0.57 accuracy and an F1 of 0.66, so not tremendously good at identifying possible threats in the system, but it could be worse. So here we have a representation of that as positive threats going up, and then it kind of just flattening out, and yeah, meeting the false positive here right here at the end of the graph. Confusion matrix, we added worse at the end, not at the end, but at the bottom of the y-axis and at the far right side of the x-axis. And the next thing I did was, I did a bunch of different configurations, but I mainly just, what I chose to do is just show my best, which is ReLU with SGD and print statement, and I ended up getting 0.86. So this is actually pretty fantastic at identifying the positive threats, and then it kind of just flattens out. And this is what the confusion matrix looks like for this one. And I believe the third thing that I'm supposed to talk about is, well, I don't think anything actually. So yeah, that was my project. I hope you guys got a little bit of information from that. Sorry, trying to rush through this, make it a little bit quick. Some things that were kind of tough during this project was basically just figuring out everything meshed together, because yeah, the project description is pretty vague, but it was really interesting once you get things working and seeing how different combinations of optimizers and activators worked for the fully connected layer. And interesting enough, the optimizers and activators for my fully connected layer, they worked well, but then when I did my CNN, those same optimizers and activators ended up providing me with a lower F1 score. So pretty interesting. So I'm excited to see what you guys did. Yeah, can't wait to see it. Alright, thank you guys.